My name is Sethu Vijayakumar. I'm a professor of robotics at the University of Edinburgh within the School of Informatics, and I'm also the director of the Institute for Perception, Action and Behavior. Today I'm going to talk to you about an exciting new project that's been sponsored by the EPSRC, and this is called topology-based motion synthesis. Creates a new paradigm shift in planning and representation. We are going away from the concepts of representing movements as joint angles and in 3D task space to completely different coordinate system, and that coordinate system being things which are useful in terms of syntactically planning and representing movements. For example, instead of saying you have an object at position X, Y, and Z, you would say the object is above something or below something or is wrapped around a particular other object. And this would be very hard to specify using traditional coordinate systems. The key inspiration is the fact that we are now being able to build robots that are a lot more flexible, a lot more versatile, and we've got new developments in material sciences, we've got new development in sensors that make, for example, individual joints a lot more compact. So what it boils down to is you can get very, very complicated robotic structures in it. You can have sort of octopus-like fingers or limbs. You can have flexible actuators. You can have variable impedance actuators. And this is great news for the flexibility of robotic systems. Unfortunately, what brings with it is more complexity at the level of planning and representation, which traditional methods of planning cannot deal with at the moment. The robotic football playing humanoids of today, for example, actually need a significant amount of time to sense, plan and react, and it doesn't look anywhere close to what humans are able to do. So we're hoping that this new paradigm will enable us to speed these sort of reactive behaviors up multifold, so that we can get things that are a lot more useful. Is taking concepts from maths and set theory and graph theory, and it is looking at novel applications of these concepts from formal methods to application domains. So animation is one application, robotics or full-bodied motion synthesis is another application, and certainly you can go even further and say things like bioinformatics, where you have complex structures which are either you can visualize them or it's in an abstract space. So even manipulation and planning in artificial biology, so to say, can be thought of in this whole framework of topology. These paradigms of working in topology space give you the tools to work in such complicated environments.